All right, folks, it's Bass Action back in action here. On this page of notes, we are going to learn to graph logarithms, and in the process of graphing our logarithms, we're actually going to review almost all of our skills that we've done in this chapter, all of our solving skills, all of our inverse skills, all of those things that we've been working on for the last several days. So let's jump into a couple basic things here at the top of the page related to our logarithmic graphs. Just a couple basic pieces of information. First of all, a transformed logarithmic equation will be in the form that will look like this. So our h and our k are going to be our shifted, our vertical and our horizontal shifts. Of course, we're going to have our base there. And if you think about the parent graph that we talked about earlier in the chapter, all of our logarithmic graphs will have a vertical asymptote, okay? And that vertical asymptote is going to pass through the point hk. Now, what we're going to find is, of course, since it's a vertical asymptote and it's going to be x equals some value, we can, of course, predict it's going to be x equals h, but there's really no reason to memorize that particular value. Now, the next thing that we can think about is that since our inverse of a logarithmic graph will be an exponential, we can remember from earlier in the chapter that it's going to reflect over the line y equals x. That's our identity. And of course, we can get that by simply reversing all of the points. Okay, so we can just reverse those points. Of course, we talked earlier about that just means switch x and y, and we'll get the new graph. A couple little reminders here related to our logarithms. We want to always remember that the log of 1 is equal to 0, and log base b of b is going to be 1. Those are going to help us make some good smart t-charts. So as we work through this, we want to organize our work well. So we're going to do a little dividing up of our workspace here. So you might want to just do this little division right away. I'm going to go ahead and just draw in some lines here so that we can kind of create some partitions here. It'll help us kind of separate our work and keep track of things a little bit better for ourselves. All right, a couple things that we're going to do that we could certainly do right off the bat without even thinking about its graph is we can find our x and our y intercepts. So we could find, of course, our x-intercept by letting y equal 0. And we, of course, can find our y-intercept by letting x equal 0. Okay, so I'm going to pause this and I'm going to let you go ahead and do that algebraically. It's just a review of our solving. So I'm going to pause this and then I want you to work out those intercepts and then restart and you can check your answers. Okay, so let's go ahead and check our answers here. So you can go ahead, check your answers, make sure that for your x and your y intercepts, you got these same values. Of course, if we were actually going to put these as intercepts, we would want to write these as ordered pairs. So down here at the bottom, I can certainly summarize this. I can write my y-intercept. I can write that y-intercept there, of course, as 0, comma, and I can write it in its exact form of log base 3 of 5 minus 2. And my x-intercept, I'm going to write that as its ordered pair of negative 4, comma 0. So we've got those, and if we wanted, we can even go ahead and we could put those right now on our graph before we even have found anything else at all. So for my y-intercept, we've already done that decimal approximation, so I can put that point here on my graph, and I can put my x-intercept on my graph as well. Now I can come up and actually just start thinking about our log. So that was just a good review. Now, making our smart t-chart, what we're going to really be focusing on here is this argument, and we want to think about this base as we're working. So when I make my t-chart here, I'm going to think about the fact that I've got some values that I want to find. So I'm going to make my little values here. And using our properties from up above, what I understand is that I would like for this argument to become either 0 or either 1, or I would like it to equal my base. Because what I ultimately want to be able to do on this right-hand side is I would like to be able to do log base 3 of 1, so I could subtract 2, and I would like to be able to do log base 3 of 3 and then subtract 2. Because if I could do that, then of course log base 3 of 1 would be 0. So then that would simply become a negative 2. And my log base 3 of 3 would become 1. So I would have 1 minus 2, or a negative 1. Now what we want to know is, how do we get those values? How do I get my argument to equal those nice numbers? So I'm going to just do a little mental calculation over here to the side, although we're actually going to write it out. So you could do it mentally, I guess is my point. So 5 minus x, that's my argument. I can see from over here that I want that argument to equal 1. So I'm going to figure out what x value will make that argument 1. So just solving this simple little equation, I would get a value of 4. And of course, I also would like that argument, that 5 minus x, I want it to equal whatever my base was. And again, I know that because I can see it right over here on the right-hand side. I've thought about it in advance. So, of course, that one's going to get me a 2. With that in mind, I now have some very nice ordered pairs that I could put on my graph. So I can go ahead and I can plot those. So I would have the point 4, negative 2, and I would have the point 2, negative 1. And using my x and y intercepts in those points, I've got 4 really good points. Now, if you're not quite seeing how this is working, what we could have done in the very beginning, but I wanted to do some review for us first, was identify this original value of h and k. What has this shift been? What's been my horizontal and my vertical shift here? So my horizontal and vertical shift has been, what value is going to make the argument 0? So that's going to be a 5. So I've got this 5, and I can see my vertical shift is a negative 2. And as I mentioned up above, the vertical asymptote is going to go through that point. So 5, negative 2. So I've got this 5, negative 2, and then I'm going to draw in my vertical asymptote through that point. So that HK point is never actually on the graph. It's where our vertical asymptote is going to go. And now I can see that my points certainly seem like they're getting close to that. They feel like the shape of a logarithmic graph, so I can just draw these in, and I can make it approach the vertical asymptote, and it's going to cross this x-axis and flatten out there. So now I've got a nice logarithmic graph with some good points. So that's going to be my logarithmic graph, and of course then if I come down here to the bottom and I fill out a few other things, I can certainly then identify that the domain of this logarithmic graph, I can look at it from the graph or think algebraically, is going to go from negative infinity all the way up to, but not including, that vertical asymptote at 5. And of course, my range for my logarithm is always going to be negative infinity to positive infinity. So that's all very useful. And then I can actually, oh, and I just realized I forgot to write the equation for my asymptote. So I've got x equals 5 there. Okay, so using all of that, let's think about how this is going to help us with its inverse, its exponential function. All of these, of course, are going to switch places. So on this asymptote, I can think about the exponential asymptote. I just need to switch the x to a y. And my y-intercept, if I reverse these two values, my y-intercept will become my x-intercept. So I can just flip this around. I don't even actually need to do any math to get this answer. Of course, my x-intercept, reversing those ordered pairs, that ordered pair is going to create a nice y-intercept. And of course, this domain will become this range. And this range will become this domain, which is really the whole point of this chapter, is really linking those together. So if we want to come up here for one last thing, we can draw in our identity line here. So I could draw in this identity line, just quick sketching mine in. It's not super straight, but it's probably good enough. And then what I would like you to do is go ahead and reverse all the points that we had on our logarithm and graph the exponential graph. So I'm going to pause this and I'm going to let you do that, and you can come back and check. All All right, so all I did was take all of my ordered pairs and I just reversed each and every one of these ordered pairs. And then of course for my X and Y intercepts, I grabbed those from down below. And when I graphed those, I got that beautiful reflection over the identity line that I was expecting to get. All right, on the next page, we are going to look at writing equations for our exponentials from graphs and tables.